would be, Sri, like that directs from your previous answer. Like, how important is data engineering and DevOps for a data scientist? And like, at what stage of their career? Like, if I started as a beginner now, should I go for it at the beginning stage only, or should I consider it as a later stage? Like when I'm started working, I'm very much familiar with all the algorithms of that, like random forest, all those things I know and maths about it. Then I should go for data engineering DevOps, I should consider, or I should like a little bit hint of that I should have at the beginning also.
Yeah, so I feel like it's better to have the basic foundations at least, right, at the
Okay.
beginning of the career itself.
Okay.
You can, as you go and work with real world scenario, you can enhance your knowledge, but it's good to
Mhm.
start with, right? Like now, if you take data engineering. Data
Yes.
engineering is kind of the foundation of any intelligent solutions, right? You be it in machine learning, be it AI, or even be it advanced analytics, right?
Yes.
Data engineering is the core component of it, right? You need
Yes.
to collect the data properly, right? That is the first aspect of it, because you are
Yes.
making a data driven decision.
Yes.
Once you have collected the data, right, you need to organize the data so that it's easily accessible, right?
Yes.
Now I might have a terabyte of data or petabyte of data. Now if you're
Yes.
going to tell the data scientists go and take it, they have no
Yes.
clue what data resides where. So you need
Yes.
to catalog the data, right? You need to kind of do a metadata management. You need to catalog the data.
Yes.
That these are some aspect of it where data engineering comes into play, and it's
Yes.
pretty key. Right now, there will be completely dedicated data engineer who does this job. But
Yes.
from even from a data scientist aspect of it, think future engineering, right? Future engineering, nothing but complex pipelines. You may have to correlate across multiple source system. You may have to do time series analysis, and you
Yes.
need to kind of have that skill set,
Yes.
our knowledge of data engineering that can work on this huge data set and then
Yes.
create those futures for you, right? Typically
Yes.
they say, right, when you start with the project, your database is in terabyte size, and when you feed
Okay.
it to your model, it's typically in the GBs range, right?
Yes.
Because the data is curated and created in a form that model can understand it and model
Yes.
can work better. So data
Perfect.
engineering like is pretty key aspect of it. The data scientist must know data engineering to the expert, that to the to the to the limit that they should be able to apply that in their model building process, right?
Yes. Yes.
And now what happens, like, if second aspect, right, if you don't know proper data engineering, you might end up in a spaghetti code. And the spaghetti code workflows, like if you see the notebook, you will have like code all over the place, right? If you don't create that data engineering aspect of it, and it will become difficult to productionize it, because
Yes.
your
Yeah.
development pipeline and production pipeline are two different things. To give an example, right, if you're doing a marketing use case, right, you typically work on historical data, which is batch, and then you build the model. And when you want to
Yes.
productionize it, typically in the real time pipeline, you want to give a marketing offer to the user in absolute 20 millisecond. So the
Okay.
training and deployment scenario is same. Data engineering makes you build a kind of robust pipeline that can be used during model building and easily deployed as well, right? So that's where
Yes.
the data engineering aspect comes into play.
Yeah. That is. Yeah. Yeah. So please continue.
Yeah. The second thing is DevOps, right? I
Yeah.
feel DevOps is also critical. The reason is a data scientist typically goes through hundreds of iteration, right? When he runs the model with the algorithm, he may never get the right answer. He may have to take features, eliminate features, add features, do
All.
additional feature engineering, and
Yes.
he goes to multiple iteration, and
Yes.
he does not know which iteration gave him the best possible outcome, right?
Outcome.
He may
Yes.
lose track of it as he's changing his notebook and doing it. So
Yeah.
having a proper DevOps, right, having a proper version control, tracking the metrics with each version control makes it
Mm.
more reproducible, right? This from the data science aspect of it. Now data science takes the notebook and pass it on to a software engineer to deploy it. The
Yes.
software engineer must also be able to reproduce it, right? So you need to have a proper DevOps. Otherwise, if you keep passing the information over email or something like that, it's get lost, right? That is one aspect of it. DevOps also comes into play in the infrastructure aspect of it, right? Like if you want to spin up infrastructure, you typically do your hypothesis on an desktop. You then go to enterprise server. Sometimes you go to the cloud. You must have a kind of the procedures where your infrastructure or the containers that you spin up
Mm.
for the modeling or training purpose is consistent. It has all the required libraries, all the
Yes.
dependencies. and everything, right? So reproducibility is one aspect, infrastructure is other aspect, logging the metrics is the third aspect, and also the deployment, right? Once you train your model, how usually you want to deploy the model, right? Do we want to provide as a container, or do we want to put it in an streaming pipeline? All this varies, right? And finally, like operations, right? Your model is deployed, the operation guys own it. They need to continuously monitor the model and alert if there's a data or code drift. So all this had to be factored in seamlessly, right? Everybody has to be aware of the end-to-end process. So DevOps is
Yeah.
pretty even from the data science aspect of it.
Yeah, so I definitely agree with that, and this makes me remember like last interview I had with Ankit Rathi. So he pointed a very good analogy for this. Like you should be a T-shape, so you should be very good at one thing, and you should have a bed of all the things. So it's always good to understand like how the data engineering pipeline has been built, and also how your model is going to be deployed and as well as monitored in the future, so that like I also read about your article also on this particular thing that data scientist work is not done once the model is ready. It also there like the data that is entering into it, is it make like monitoring the data that is entering into the model once it is deployed. So that is also a very important aspect, and we don't like in our courses or like the online courses that we have, we are not taught about this. Like if I take any of the online courses of data scientists or something like that, so they'll teach me random forest, they'll teach me all the ensemble methods and all those complex things. That's nice to have, but they won't teach me this like how to do ETL tasks. They won't teach me how to do like how to be, work with Kubernetes, deploy that on that. So they are there, but they are not termed or they are not included as a part of data science. So
Right, and this is where the real world stuff also comes into play, right? Because if you hire a researcher or PhD, right, he may be
yeah,
very good in building model, and they are very
yeah,
ad hoc guys. They may read a new research paper, change their model and everything, right?
yeah,
But they are not typical software guys. So you need to set up and process and methodology where the research is taken into production, right?
yeah,
That's pretty important, and you need to master it, right? As
yeah,
you said,
yeah.
and master what is required. These are the things you can learn on the job, but know the process that will help you.
Perfect. Yeah. So that leads to the second question. So as the resources are not termed as data science needed things, like they are not in our data science courses. So are there some resources or some blog posts or something like that that you would suggest for a person who is interested into this, like getting some introductory knowledge for data engineering and DevOps? We should like consider that.
Yeah, so I think like data engineering, there are quite a good number of courses, but what I would say is, right, the data engineering tools are also endless, right? You
Yeah.
you have a lot of frameworks, a lot of databases. It's very
Yeah.
difficult to master all. So pick
Yeah.
the one that is very prominent, right? Like what I would say is,
Yeah.
in spite of all the hype that Hadoop is dead and something, the news that you have been seeing, right?
Yeah.
I would say like learn the distributed system concepts, how it works, because
Yeah.
all the distributed capability that was built after Hadoop is based on the idea of Hadoop, how to distribute
Yeah.
your data and compute, right? Learn the underlying principles of it. You need not go and learn pig or MapReduce or something like that, but learn the concept and then concentrate more on Apache Spark, right? See, Apache Spark or Apache Beam is the prominently used tool for a data scientist, right?
Always.
For data engineering, right? It's always good to learn Apache Spark and or Apache Beam, I would say. One more advantage of Apache Spark is it's not only a data engineering tool; it's a end-to-end machine learning tool as well. So
Yeah.
it has, yeah, it has inbuilt algorithms.
Yeah.
It has your data engineering pipeline, so you can just build end-to-end. You can deploy it. Most of the
Yeah.
prominent algorithms, if you see XGBoost and TensorFlow, already as a wrapper for Spark. So there's
Yes.
Spark TensorFlow and Spark XGBoost
Yes.
that works very well with distributed training. So I would
Okay.
say like learn Spark. There are websites like Mapper that Apple offers you free Spark course.
Yes.
Databricks is a very good website. They have a pretty elaborated ebooks, right, for both data engineering and data scientist. You can
Yeah.
download the ebook, it's free of cost. They also give you a community edition environment where you can
Yeah.
go and practice it. So you
Yeah.
can
Yeah.
just register, you can go and practice it, and
And
they give, go ahead.
sorry to interrupt, they are very user friendly also. Like they are not very complex to understand. So I have been through them, and like I was able to complete them, like most of the key concepts in very less time. So they are very user friendly as well.
Agree. And one more thing, what I realized, right? If you're doing an Spark ML, right, it is very similar to scikit-learn pipelines. You just have
Okay.
to relate one tool to other. How this tool works with the other tool.
Okay.
It's very easy to learn. There's a Python wrapper to it. You don't have to really do it in Scala. I know if you take about Spark 1.5 and 1.6, Scala had a
Uh,
lot of rich features which Python did not have. Right
yes.
now, Python is almost catched up with what Scala is. It's very,
Uh,
very easy to use. Once you learn the
uh,
concepts, you can do anything with it. You can do wonders with it on very large data set. Right.
yes.
So
Yes.
learn this. I think this should be good. And as you get into the job, maybe if you're working on Google Cloud, that's better option, right? Your cloud data proc, your BigQuery, and multiple other things. You can learn
Yeah.
it on the job. All right.
Yeah. It's completely different world altogether. Like
Right.
once you
Right.
get into a job, then only with a hands-on practice only you will learn that.
Right. And if you're planning to build your career on data engineering, it's good to know like NoSQL databases, streaming pipelines like Spark streaming or even Kafka or something like that, the other
Uh,
aspect of it.
uh,
So as I said, the learning is endless, right? Learn the key concepts and
yeah.
you can do on the job.
Yeah. So I think you have one blog or article on that, like resources for learning data engineering. I guess on LinkedIn.
Yeah, that's a post.
That's a,
Over
yeah.
there.
So I'll post like I'll put that link of that post in the YouTube video. So anyone if one is interested in the field of data engineering also can refer to that post. Okay.